All right, so number 14, Joyce is giving a collectible set of 8 autographed golf balls packaged in a cube-shaped box and a Caitlin Clark autographed basketball in a custom display box as graduation gifts to her niece and nephew. If the box for the golf balls has a volume of 64 cubic inches, how much wrapping paper will Joyce need to wrap the gift? So the only thing they gave us is the volume. Is there anything else that we have in part A? The only thing I saw was that volume of 64 cubic inches. Did you guys see anything else? Okay. Since they gave us the volume, we're going to have to use what formula? The volume formula. What shape is the box again? It's not a square. Square is a flat shape.
Sorry, I was instructed, sir.
Thank you. What's the shape again? A cube. What do you know about a cube that makes it special other than just a normal box? All the sides are the same size. So do we know how big the sides are? Nope. So I'm going to call this one X. This one over here would then also be X. And the height would be X. So length, width, and height would all be the same. I don't happen to know how much that is, but it's all the same. Is this a cone, a pyramid, a prism, a cylinder, or a sphere? A prism. How do we find the volume for a prism? You guys can look up the formulas. I give you the formulas to use on the test. What is the volume formula for a prism? Area of the base times the height. Be careful. Don't say base times height, because a lot of times students are just grabbing one number from the picture and plugging it in. You always have to calculate the area of the base. This number right here will not be a number that you can go look at the picture and just grab. What shape is the base of a cube? Square. How do you find the area for a square? Side squared. So we have side squared times the height. What did we write down for the side length? X. So I would have X squared times the height, which is X. What is X squared times X? X cubed. All right. I can take this 64 right here and put it in the place of what? Is that going for X or for V? V. That is the volume, so it goes in for V. So I have 64 equals X cubed. If that was X squared, what could I do to get rid of the squared? I could do a square root. It's not a squared, though. It's a cubed. How do I get rid of a cubed? Cubed root. Do you guys remember what a cubed root looks like? Looks like a square root symbol, but out in the front, it has the number for the root that we want. We want a cubed root, so I'm going to put a little 3 out there, and if you do it to one side, got to do it to the other side. So we have a cubed root on both sides. Just like a squared and a square root cancel each other out, a cubed and a cubed root will cancel each other out. So I have just X over on the right. To do a cubed root on the calculator, first you have to put in the number for the root that you want. So you have to type the 3 in first. Then you have to tell it that you want it to be a root. Second, and the caret button right here. If you push second and this button down here, that'll be 3 times a square root. That will not be a cubed root. So 3, and then second, and the caret button. It'll make your 3 a little bit smaller, and it'll put it like up in that little crook of the radical symbol. And then we put 64 in, and you get what? 4. Do we have units that would go with that? 4 inches. All right, so over on my picture, everywhere where I had X, I can actually replace that with a 4. This is 4 inches. This is 4 inches, and this is 4 inches. Did I answer the question? No, what was the question? How much wrapping paper? What am I asking for if I say how much wrapping paper? Surface area. One of the things I want to warn you guys about tomorrow, if I ask how much can fit inside or how much wrapping paper would be needed, I'm asking for volume and surface area, but it won't say find the volume, find the surface area. I will not be able to tell you on the test tomorrow which one I mean. One of the things that I'm going to be assessing is, do you know that to cover the outside means surface area? Do you know that to fill up the inside means volume? So you have to know those pieces so you know which formula to go and grab. What is the formula that we have for surface area of a cube like this? What kind of a shape did we say a cube was again? A prism. How do we find the surface area for a prism? 2b plus pH. What does the capital B stand for again? Base. Area of the base means area of the base. Remember, this is always something you have to calculate. I know that there are quite a few people still that would just grab this 4 and plug it in for B. You can't do that. It is the area of the base. And the shape of the base of the cube is specifically a what? A square. How do we find the area for a square? Yep. The length of the side squared. Not number of sides. Be careful there. It's how big is each side. And then times itself. And then the capital P stands for perimeter of the base. All right, so I can do side squared because how big are the sides here? 4, so 2 times 4 squared. What is 4 squared? 16. So I have 2 times 16, which would be what? 32. All right, so that's the area of my two bases plus the perimeter of the base. You said the base was a square, right? How would I find the perimeter of that square? Multiply what? 4 times 3? 4 times 4. Is it 4 times 3 or 4 times 4? 4 times 4. Why 4 times 4 and not 4 3? Because there's 4 sides and each side is 4 inches. So we're adding all the way around. 4 plus 4 plus 4 plus 4. So 4 times 4 times the height. What is the height? Another 4. 4 times 4 times 4 gives us, see, that'd be 16 times 4, right? What is 16 times 4? 64. Or you could just do 4 times 4 times 4. We add these two together and we get what? 96. What kind of units should we put with that 96? Inches squared. Nice work. All right, that's number 14, part A. We're still going to do number 14, part B. Part B is for the other gift that Joyce is giving. What's the other gift? What's the other gift that's being given? Basketball. The basketball is inside of a box. What shape do you think that box is? Also a cube. What do we know about this cube? .5 square inches of wrapping paper. That is the surface area, yes. And what do they want us to find? How many cubic inches of space does the box hold? If I want to know how much a box can hold, what am I asking for? Volume. All right, this is very similar to the last problem that we just did, part A, in that I don't know how big the sides are, but it is a cube. So whatever I call one side, I'm going to call the other sides the exact same thing. Since I used X last time, you guys okay if I use Y this time? It's okay if you use X again. That's fine. So length would be Y, width would be Y, and the height would be Y. Surface area, you guys just told me the surface area formula for a prism. 2 times the area of the base plus the perimeter times the height. What shape is the base? Still a square, so side squared plus the perimeter times the height. What are we calling the side length? Y. So I would have 2 times Y squared plus the perimeter. How many sides does the base have? 4 sides. How big is each side? Y. So I have 4 times Y times my height, which is another Y. All right, let's simplify this. 2 times Y squared would be 2Y squared. Plus, and then I have 4 times Y times Y. 4Y squared. Can I combine those two? Are those like terms? Yes. So 2Y squared plus 4Y squared would give me 6Y squared. I can take this surface area of 541.5, put it in the place of the SA. 541.5 equals 6Y squared. And what would I do from here now? Divide both sides by 6. Not 6Y squared, just the 6. We want the Y all by itself, so I'm leaving the Y in place. What is 541.5 divided by 6? 90.25 equals Y squared. What do I do now? Square root. And if you do it to one side, got to do it to the other side. The squared and the square root cancel out on the right. We get what? 9.5. 9.5 what? Inches. 9.5 inches. So over here where I had the Y's written, I can replace those with 9.5. 9.5 inches. 9.5 inches. 9.5 inches. And we've been asked to calculate the volume. How do I calculate the volume for a prism like this? Area of the base times the height. What shape is that base? Square. And I find that area by doing what? Side squared times the height. How big is the side? 9.5. So I would have 9.5 squared times another 9.5. How much space is there inside the box? .375 inches cubed. Nicely done. What else would you guys like to see? Number 11? Absolutely. Flip backwards one page. Here we have number 11. It says a rectangular box. So are we working with a cube? No. A rectangular box contains 3 balls which lie flush against all of the sides. The volume of one ball is 14.137. Put that away and get your review out. Part A says, what is the radius of one ball? The only thing they gave us was what? They gave us the volume. Volume of what? One ball. What shape is the ball? A sphere. Sphere. Circle's flat shape. Sphere is 3-dimensional shape. Since they gave me the volume, what do you think I'm going to need to use? It said find the radius, but I need to use what? What'd you say? The volume formula. What is the volume formula for a ball, for a sphere? 4/3 pi r cubed. What can I substitute in? I can sub in the volume, right? In the place of the V, we're going to put 14.137 equals 4/3 pi r cubed. We've got a fraction there. While I'm solving for r, I'd really prefer to not work with fractions. How can I get rid of that? Multiply by the denominator. So what are we going to multiply by? 3. If you do it to one side, got to do it to the other side. One of the things I want to point out, over on the right, where I'm multiplying by the 3, why am I doing that again? To get rid of my denominator. If my denominator cancels out with this number out here, then that 3 on the outside doesn't affect anything else. I don't times that 3 by the 4 up on top. It cancels out, it goes away, so it has no impact on anything else there.
So it cancels out on this one.
Cancels out over on the right. So the 3 on the outside and the 3 in the denominator cancel each other out, and that 3 on the outside doesn't touch anything else on the right.
Okay.
Yep. So over on the right, I would have 4 pi r cubed. What would I have on the left? 42.411. All right, what's my next step? Division. What are we dividing by? By 4. Okay. What do you get when you do 42.411 divided by 4? 10.602 equals pi r squared. I am running out of room, so I got to bring that over here. 10 point, did I write squared? Cubed. Yes, thank you. Cubed. Thank you for correcting me. 10.602 equals pi r cubed. What's the next thing I do? Divide by pi, yes. We're going to divide both sides by pi, so that cancels out my pi. What is 10.602 divided by pi? You said 3.374? 3.374 equals r cubed. Close, not a square root. Cubed root. Cubed root looks like a square root, except it's got that little 3 out in front. So the cubed and the cubed root are going to cancel out over on the right. I have just r on the right. 1.499. Do we need units with that? What units? Inches, yes. 1.499 inches. So that means from the center of one of these balls over to the edge, it's 1.499. But I could go from the center down here to the bottom edge. I don't have to go left to right. That would also be 1.499, right? Part B asks me to find what? What do they mean by dimensions of the box? means length, width, and height. Those are dimensions. So I need to figure out how long this box is. If from the center of the ball to the edge is 1.499, how wide is one ball? Yep, 1.499 times 2. 2.998, not squared, but times 2. Sorry, somebody said the 3.374, which I can understand, but we're not timesing it by itself. We're adding it to itself. All right, so one ball is 2.998. So how wide is the next ball? 2.998. How wide is the third ball? 2.998. So what would I need to do to find the width of this box? Add them all together, or I could times it by 3. 3 times 2.998. 8 point what? 8.994 units. Inches. Not inches squared because it's not area. Not inches cubed because it's not volume, just inches. How wide is the box then? .998, yes. There is only one ball. It's one ball high and one ball deep and 3 balls long. So one ball deep would be 2.998. 2.998 inches. What is the height?
2.998.
Away. This is not optional, and it's no longer a request. I have been as polite as I can possibly imagine. Put it away or put it up there. 2.998. Because that is the height of one ball. Yes. Yep. So back here, this 10.602, if you round that one, because there were digits after the 2, I rounded mine to 10.603, which changes this number right here to 3.375, and that would round this one here to 1.5, which would mean that we would have balls that are 3 inches wide instead of 2.998. I would be perfectly fine with rounding like that. Yep. What else would you guys like to see? Number which one? 3, absolutely. Let's go look at number 3. Before we get too deep into number 3, what is that shape there? I know it's a box for chocolate, but what shape is it? Triangular prism. Remember, a pyramid comes up to a single point. All of the triangles will touch each other in a single point. In a triangular prism, the triangles will never touch each other. What do we know about this triangular prism? The bases are equilateral triangles. What do we know about these equilateral triangles? Side length of 4 centimeters. So here is 4 centimeters. Here is 4 centimeters. And here is 4 centimeters. Same is true about the one on the back side, but I'm not going to write all that out. But he's exactly the same back here. What else do we know about this box? Yes. Of this? When I'm done with this one, yes. What else do we know about this? What is 15 centimeters? The box. So from here to here is 15 centimeters. That is the distance between the two bases. which means even though this thing is laying down long ways, this is the height of the prism. The height of a prism is always the distance between the two congruent parallel bases. It doesn't matter if I lay it down or I stand it up or any other thing. The distance between the two bases will be the height of the prism. What do they want me to find? Starts off with how much wrapping paper, which Sarah means what? Surface area. What's our surface area formula for a prism like this? What's our surface area formula for a prism? Nope. What'd you say? LA plus B? 2B, because we have two bases. We've got one triangle on the left and one triangle on the right. Plus, and then you said LA. What do we mean by LA? Lateral area. Lateral area is all of those rectangles around my bases. How do I find that area? Perimeter times the height. All right, so capital B is area of the base. And what shape is the base? Triangle. So I need an area formula for a triangle here. There were two different area formulas that we learned for triangles back in Module 11A. What was one of them? Yes, in a minute. 1/2 base times height. Actually, we are 10 minutes past when they closed the bathrooms. I'm sorry, I just glanced at that time. 1/2 base times height. Do we know the height of the triangle? No, that's the height of the prism. No, that's not the height of the triangle. That's a base of the triangle, and it's all the sides, but the height goes from the base up to the point. Do we know from the base up to the point? No. Does anybody remember that other area formula that we had? Yep, 1/2 AB. What was the rest of that one? Times the sine of angle C. Plus that capital P means perimeter of the base. And what was the shape of the base again? Triangle, perimeter of the triangle. How would I find the perimeter for this type of triangle? 4 times 3. We're going to do the number of sides times the length of each side, and then we're going to multiply by the height. All right, let's plug in everything that we've got now. I have 2 times 1/2. What do I have that I can put in for A and for B? 4 and 4. 4 goes in for A, 4 goes in for B, times the sine of, I need an angle in between my two sides. Well, I know that all 3 sides are the same size, right? What's that mean about those 3 angles then? They're all the same size also. How many degrees do the angles in a triangle add up to? 180. So it's going to be 60. We do 180 divided into 3 equal parts. And that gives us 60 degrees. So this angle right here is 60 degrees. So sine of 60. Plus the number of sides times the length of each side. That would be 4 times 3. Times the height. What is the height? 15. The height is the height of the whole prism. All right, let's do this in 2 parts. Let's do the area of the 2 bases first. 2 times 1/2 times 4 times 4 times sine of angle C. What do we get? $13.856 plus 4 times 3 times 15. 180. So then we add those two together. I get 193.856 centimeters squared. Part B, how much chocolate is contained inside? That is what? That is volume. How do we find volume for a prism? Yep, area of the base times the height. What shape is the base? Triangle. How are we going to find the area of that triangle? 1/2 AB times the sine of angle C times the height. What goes in for A and for B? 4. So 1/2 times 4 times 4 times the sine of what? 60 degrees. Make sure you close the parentheses around the 60 degrees before you put in the height. What is the height? 15. So we're going to put this all into our calculator, one big long thing. Make sure you close the parentheses around the 60 degrees before you times it by the 15. A little bit louder. 103.923, and that would be centimeters cubed. Somebody asked me a really good question earlier today. They said, will the surface area always be more than the volume? No. The smaller your object is, the surface area will be bigger than the volume. But as your object gets bigger and bigger and bigger, eventually the volume will overtake the surface area. So you cannot just look at this and know, oh, I made a mistake because volume is too small or because volume is too big. Depends on the size of your actual object. What else would we like to see? I got time for probably one more. Number 5. Let's go look at number 5. How many cubic feet of payload, cargo, could this rocket hold? This rocket is made up of what shapes? Cylinder and a cone. If I want to know how much it could hold, what am I asking for? Volume. So we need to do the volume of the cylinder plus the volume of the cone. How do we find the volume for a cylinder? Area of the base times the height. What shape is the base on a cylinder? Circle. How do we find the area of a circle? Pi r squared. So this is going to be pi r squared times the height. Plus, how do we find the volume for a cone? One-third pi r squared times the height. All right, so we need to figure out the radius, which is going to be the same radius for the cone and the cylinder. And then we need to figure out the heights of these two separate objects. I will not use 180 for the height anywhere in this formula. The 180 is the height of the whole thing. What is the radius? 40. This much right here would be 40 feet. And that's going to be true up here for the cone also. So for my cylinder, I do pi times 40 squared times the height of the cylinder. What's the height of the cylinder? 120. All right, let's put just that much into our calculators. What does that give us? .603, 185.789. Plus, now we have to go do the cone. The 1/3 stays there. Pi stays there. What goes in for R? 40. So I have 40 squared times the height of the cone. 60. How'd you get 60? 180 minus 120, yes. So 1/3 pi times 40 squared times 60. What does that come out to be? $100,530. Point. You said 964. 964. Then we have to add those two together. So we get 703,716.753 feet cubed. Thank you much. All right. That is unfortunately all I have time for right now. Answer key is already posted in Canvas. Oh, Michael, you wanted one back here. Let me go back to the one you wanted. There's the one that you asked for. You will be turning in this test review tomorrow. This will be the next to last thing you turn in for me. Answer key is on today's Canvas page, along with all of the videos from previously in the day. The video will be going up later, but these are the ones that would interest you guys because I went over questions there that I didn't go over in here. Down at the very, very bottom, you can click here for the solutions for all of my work on every single problem. Just in case somebody wanted to go over question number 1, that was the first question that I went over in first period. So if you need to hear a talk through of how to do number 1, watch that first period video. It's in the first couple of minutes.